So, uh, yeah, you haven't watched the videos. I'm assuming you is what you. It says, I admit I have watched the videos this week. I haven't, yeah. I figured as such. Um, Fine. There's a lot to go over. I can go over some of the things. So let's see if we can find something nice and easy and doable in terms of the videos. Because quite frankly, I'm getting ahead of myself to a certain extent. I mean, it was other instructors were getting ahead of themselves as well. But in recent years, the instructor for 2400 would just, I don't think they even covered model view controllers. They may cover inheritance, but it was, fairly short. So what we would have in the past was you'd be getting multiple exposures to the same concepts. I know you guys are going to be doing Waves class, which is data structures, and you're going to be hitting some of these concepts again. I'm okay with that because if you've seen a linked list twice, you are more likely to remember what a linked list is. Now, you don't need to just necessarily, the point is not to memorize what a linked list is or how it works. It's more to think of the concepts. What does this tool let me do? What does this tool, what benefits do I get from this tool? So for example, a linked list. I can add elements to my linked list. I don't have to make a brand new linked list. Like with an array, if I run out of space on an array, I got to copy everything over to a different array and update my pointer. If I want to add something in the middle of my array, I got to shift everything over and add the item. With a linked list, I just have to find where I'm going and insert the item. Finding the item takes time, which is part of the problem with a linked list. So they all have trade-offs. There's no right solution in all cases. They're just different levels of problem. What I've done, I think, in the lecture videos is I do I think it's I think I do a stack with a linked list. So it's been a while since I looked at the video, so let me try and remember what I'm doing here. I do a stack with a linked list. Now, a stack looks like a stack of trays, like what you would do anytime you see anything with a stack in real life. A stack, things pile up, you take from the top, you add to the top, right? Like trays. So if you're at a cafeteria, that when the new trays get washed, they go over to the other trays, plop them on top of the old trays. You're always taking from the top. That's what a stack is. The point of these things is to make sure that you don't get in your own way. And it sounds kind of silly, and I think more than enough programmers, I think probably myself included, but more than enough people when they start go, what's the use of that? That's stupid. Why are we doing all of this? It's so much more powerful to be doing it the other way, right? Why do we need lines on the road? It'd be so much more flexible and you'd be so much more free if you could drive wherever the heck you wanted, right? On either side of the road that you want. That way, if you take a corner, if there's no lines in the road, you can you can go on the outside and then sort of skid on over and you wouldn't have to worry about going too close to the wall or something like that. So why have lines in the road? Why have stop signs? That means I have to start and slow down a bunch of times. No. Let's get rid of all the rules of the road. Let's get rid of lights. Let's get rid of lines. Let's get rid of all that stuff. That's what we're talking about here. By not having that structure, by allowing you to do whatever the heck you want. You have an array, you can put stuff anywhere, you can take stuff out of anywhere. It means that because of the free-for-all nature of it, when you have a bug, you're having one heck of a time trying to figure out what happened, where it's coming in, what's happening. A stack, let's say, means the only thing, if it's going to go onto the stack in a particular order, it's going to come off the stack in a particular order. You have certain guarantees about how the stack works. You don't have some program that you have doesn't magically go to the bottom of the stack and pull something out or change something. They can only manipulate or deal with the top of the stack. It's the only thing anyone can see. Cognitively, it's the only way to keep yourself sane. In fact, that's what your function, every time you call a function, it puts it on a call stack. The computer is actually using a stack. It is using, every time you call a function, that calls a function, that calls a function, it adds another layer on this stack. And then when you're done with the function, you remove that layer. And you're done with that function, you remove that. And you go down that way. Because if you could suddenly jump around in that call stack willy-nilly, you'd never be able to debug your program. That sort of rigor is what we're talking about. This is where we get into our standard template library. That's what one of the big things we're going to be hitting next. That's how we're getting to hash tables. Hash tables give you certain functionality, certain characteristics. Why we have iterators, right? What I don't want to know is how the person did it. I don't want to know how their code works. I don't want to know what their variable names are. I just want to have a tool that I can use, right? When I drive a car, I just want a car. I don't want to have to open the hood. I know some people are disagreeing with me on this one. There's a couple of mechanics in the course. If I have a car though, if you're a mechanic, fine, but most people just want a damn car to drive. I don't want to know how it works. I don't want to know about, what kind of suspension I have and all this kind of stuff. I just want something to drive, get me from point A to point B. When we're dealing with these tools, I want to be able to know how to build something like this that has this abstraction, that has this concept of this concept. You do not need to know how it's built. You can just use it as a tool. So we're showing you what's under the hood with the assumption or the premise that afterwards you never pop the hood again. That when you make a linked list, you know how it works. You don't need to touch that anymore. Now you can actually use it, and that's a different thing. The standard template library is that. It is, I got a bunch of tools, I can use them now. So let's actually see if we can make something with a standard template library. Let's see what we have here. So I have a priority queue. What other things do I have? I have, let's say, a list, I think. If I can type list, is it called a list? Okay. List. Maybe it's a linked list. I'd have to look up, let's use a vector. Vector will do it. All right, what's a vector? It stores stuff. That's all I know. This thing, I can put stuff on my vector. So here's what a vector is, what we know as a vector. It is not the linear algebra version of a vector, by the way, in case you know your linear algebra. This is just this concept. It's similar to an array list if you've ever seen that in JavaScript, Java. Similar, not the same. This thing allows me to stuff things into this data structure. I can just keep on adding things to this data structure. It always goes at the end. And I don't run out of space. That's what a vector does. So I can keep on. So let's say txt list dot. I can push back. I can get the beginning thing. I can get the size of it. I can get something at a particular position in my, at position 4 in my vector. I can, so what does push back do? Push back, 1 overloaded method. It's the end. I can clear it. So get rid of all my data. I should be able to get the last end. Like remove, insert. Where do I insert? I can tell it where to insert it. That's fine. Pop back, push back. Okay. So this push and pop, we're actually going to see with a queue. That's not queue. That's a DQ and NQ. Push and pop is normally used for stacks. You push something on the stack, then you pop the stack. You will literally hear computer scientists and really big nerds talk about popping the stack when they have to change topic. Can we pop the stack? Can we go back to the previous topic we were talking about? Can we pop the stack, they'll say? And can we push this on the stack if we want to change the topic to something else? Really nerdy. Holy cow. I say it too, but so I'm not really blaming anyone else on this one. The idea is for a stack is I can add things to my stack. So like put another tray on top, or I can remove the tray from the top. I can't go to the bottom of the tray. I can't go to the bottom of the stack. I can only grab, if you've ever gone to a buffet and someone tries to root through all the trays or root through all the plates and get the one at the bottom, you'd like, slap them upside the head. You'd be like, what are you doing, buddy? You take the one on the top. If it's dirty, take it off, take the next one, fine. But you don't go rooting around putting your dirty old hands on all the plates, right? You just don't do it. Same thing with a programming stack. I could take the top thing, I can put something on the top of that, but I'm not rooting around to the other stuff. A vector does something very similar. I could add to the end, I could take away from the end. That's it. So here I am. I have made a vector, standard template library vector, and I'm going to push on the back of it. You need to know how it works? Not in the least. So, and I'm going to put hello world, right? And I'm going to text list dot push back. So again, and let's do the last one. Goodbye. All right. The whole point of something like this. Do I know how a vector works? No clue. Could be using an array. It could be using a linked list. It could be using anything. I don't know. I don't want to know. That's the point. I can get data different elements, but this vector could be built with a linked list. It could be built with an array. It could be built with whatever you want, whatever tool you have in your language. That's the point. I don't want to know how it works. So I have these things, and then let's do a cout statement. Element. Okay, I'm going to put it in a for loop for int I is equal to 0. Actually, let's do it this way. Let's do a while loop. While text list dot has, does it have a has element? Size. That'll fix this wagon. All right, the size of this. While this size is greater than 0, here's what I'm going to do. I'm going to output something this. By the way, I'm filling time until you guys ask questions in case you didn't know. So ask away. You're not going to stop me or slow me down at all. So what do I want to put in here? I want to have text list dot. If I pop this back, what happens? Does it actually return a value? Pop back, takes a string. Oh, it's a void. Notice at the very front it says void, as in I pop it. I lose that last element. Okay. So I want to move. I'm going to move this to a new line because I know I'm going to need this thing. Text list dot get last. Let's just last actually. Is it last? Insert. That's what insert does actually. It will insert it at a particular point. Okay. What does this do? This will, it gives me the iterator to the very last one. And we can talk about iterators all you want as well. Okay, so let's see if we can do this. It's going to be at. So at the last element, I'm going to output and let's do empty. So this is testing to see if this thing is empty, if it has nothing in it. It's then going to output what the last element here is, because I can do with that. And then I'm going to remove the last element there. Notice the vector doesn't say I only get the last element like a stack does. A stack says, no, the only thing you can see is the last element. This says you can look at any element you want. You can only remove from the back. You can only add to the back. I think you can technically insert earlier, but it's harder to do. Pushing something at the back, just adding it to the back, is what you're supposed to be doing with a vector. Always add to the back. Add to the end of the line, right? At the end of the whatever you have. So until this thing is empty, I'm just going to keep on pulling off, finding out what the last element is, printing it off, and then removing that and then removing the last element. I'm hoping this thing will not go to an infinite loop. But let's find out. Because why not? Fun. Let's see if it catches fire and causes all sorts of heartache. So this thing, I'm going to push 3 things each time. So I have a list with nothing, then I'm going to add an element, then I'm going to add an element, then I'm going to add an element. Each time adding it to the back. I'm not sure if my image is flipping around, so I don't know which way my hand should be going. Is just adding it to the back of the list. So it's going to say hello world, hello again, goodbye at the end. And then I'll remove the goodbye, then I'll remove the hello again, then I'll remove hello world. With me so far? What the heck? Let's do a for loop just so in case you don't believe me. And I is equal to 0, I is less than x list dot size of this vector that I have here. And again, let's be very clear. I don't know how the hell this thing is put together. I know nothing about the vector class. I don't want to know anything about the vector class. You can't make me. That's the point. I want a tool that I can use, not that I have to know exactly how it's built from the ground up. All right. So in this case, I'm going to see out vector the that text list dot add, and I'm going to put I in here. All right. So it's going to print off all the elements one after the other. And then afterwards, I'm going to pop from the back, all the while saying what that element I'm popping off is. It's in the standard template library. And in case you're wondering what the heck that is, let's we just build it and make sure it works. And I'll show you that. Okay. Here it is, right there. The standard library it gives us sorting. It gives us a whole bunch of ways of collecting and storing data. So it gives us a priority queue is another thing that it has. It has vectors. It has, I think, collections. It has sets. It has a whole bunch of things. It is a grab bag of stuff that you can use. And more importantly, until you need to use it, don't use it, right? Until you need a collection, there's no point memorizing what the hell a collection is. Figure it out when you need it. That is the default working operation of how you use these sorts of things. I don't know what I need. Does the standard template library have anything for me for that? I don't know how to sort this array. Maybe the standard template library can help me with that. And you'll find out if it does. Let's also see if I can sort. I want to see if I can sort this thing too. What the heck? So by sorting the. Okay, we'll try that in a second. Let's see it in action. Hopefully it's going to work. So what do I have here? I have hello world, hello again, goodbye. So that's the order that they got put in. It always got added to the end of the array or the vector. Right? I'm always adding to the end. It's pushing at the back. And then I got the next. Those are the priority queue, vector element. Oh, that's vector element. Both vector element. Let's see what this thing does. I'm curious. Oh, that one down here is not being called at all. So I didn't empty any of my vectors. Removed. Okay. And so I have, if it's empty, while this is not empty, I had a size there. I had just a stupid typo in there. Let's run it again. So while thing is not empty, I'm just going to keep on popping the back. So removing an element until I run out of elements. Let's hope. See, vector element, hello again, hello world, hello again, goodbye. I remove goodbye, then I remove hello again, then I remove hello world. I remove from the back as well. That's how vectors are designed. And again, I don't know how it works. Your autocomplete is your friend there. You start typing something, you push dot, and you go like, well, what's the possibility? Empty. I wonder what that thing does, and look it up. Honest to God, it's what every single programmer does. It's sort of what, flying without a net, or trapeze without a net, whatever the term is, right? There's no safety net here. You don't necessarily know what you're going to be looking for. You can look up other examples, but that's essentially what we do. We just autocomplete. Oh, that's what's available. Let's see if I can sort this. So I have a vector. Let's see if the vector can be sorted. So qsort would be one of the functions. I have this number of elements, size of the init elements. I think I have a bunch of different qsort. Qsort. Well, let's just try and call sort and see what happens. Is there always sort? First, last, templated class, partial sort, qsort. Let's see qsort. Let's see if I can get a qsort up and running. Hopefully I have a bunch of different things that'll work. Index list. Will that actually work? Let's find out. No, it will not work. Okay. Okay, that's a vector. It takes in a string. Oh, you see here. It doesn't take one parameter. Okay. Let's see what other things I need to include. Oh, I don't want to be doing that. That's looking scary. I don't like that. We're having it with an array and a hash table for the assignment. That's why I was okay with it, because here's the array that'll be passing in here. It's a pointer to the array. Here's the size of my array. The size, this is the number of elements, so how big the array is, the size of each element in my array, and then if we have a comparison function. We try the number of elements. So how big is each one of those things? It's not going to work for us. Or I'm not going to be able to figure it out on the fly. The point of this, though, is I have sorting functions that if I have an array of elements, I can just throw it into a quick sort array and it'll work. So let's see here. Nums, and it's going to be size 10. Okay. Let's see here. For any size 0, I is less than 10. All right. And nums at position I equal to I times 10, let's say. So it's going to be 0, 10, 20, 30, And then, oh, missing that close friend. And then I'm going to call Q sort on nums, already a pointer. And the size number of elements is 10, and the size of int. And I'm not sure if I need that comparison function, so let's find out. I'm really surprised. So I'm going to do it. Oh man, I'm blanking on how my sorting algorithm is going to work. I gave it in the instructions. So um, I'm obsessing here. Base, number of elements, size of the elements, comparison thing, context. No, that's not going to work. That's not going to work either. I don't think that's not even our sorting algorithm. STL. Ah, right. I'd have to look it up. I'd do a search online for this one. The reason I'm pointing it out is just because it has sorting algorithms that you can just use. And I thought it was QSort, but I thought QSort did not require all of this gobbledygook. I thought it was a pass in the array, say how big it is, done, and you're done with it. I don't know why it's not letting me do that, because what it should be doing is it just sorts my entire array for me. So let me bail on that part just for now, at least. But it has sorting algorithms. It has ways of collecting data. It has what other things? It has priority queues. It has it has iterators. It has different kinds of iterators involved in it, and it has different ways of accessing data. So it has a lot of different things inside of it. We're just looking at one with a vector. Here is a priority queue. I am going to make a priority queue, which takes in type string. It can be any class that I want for priority queue. The one thing I desperately need with a priority queue is that I need to be able to compare different elements. I need to be able to see if this comes before that. So I can make a priority queue of integers, not a problem. I can make a priority queue of strings, not a problem. If I have another class, I need to implement the less than operator in order to get a priority queue working, because it automatically sorts when I add things to the queue. It's a queue is a list. That's all it is. It's a lineup. Like if you're waiting to get into a restaurant or something like that, or waiting restaurant. What are those things? Waiting to get a COVID test, right? Queue, right? It's just a lineup. And first one in, first one out. A priority queue is first one in, first one out, unless someone's in an emergency, then they get to jump the queue or they're VIP, right? Priority queue is you go in order of the importance of your case, but if two things are equal, first one in, first one out. So that's what a priority queue is. I'm asking you to make a priority queue because what you could do with a priority queue, like here, I am pushing in the text hello by, let's say hello 2 by 2. And then with my priority queue, I'm going to it's going to pop off the first one each time. So removing the very first one each and every time. I get what the very first element is. I remove that first element. I'm going to print off the elements, and let's see this in action. Hello tube, bye two. Hello. I'm surprised actually with this one. Oh, lowercase and uppercase. So I'm a little surprised by that the H comes before the other elements. Right, the first element in, and then I'm popping off the front of it. So it should be the order in which, in terms of alphabetical order, it would seem that that's reverse alphabetical. Right? By comes before hello in the alphabet, and then by lowercase comes before hello uppercase H because of the ASCII values. So this is actually in reverse order, which is kind of surprising. Oh, it's just going to put it in reverse order. So what could you do instead? Let's use what could we do? Well, we could actually just use a queue. And you were probably saying, what? Let's make, we can either make a queue data structure or what other things could I use? I could use a vector. Oh, that'll do it. Let's make a vector. We're going to add to the back of the vector each time. And then if I remove from the back of the vector again, it will be in the right order. So here goes nothing. Remember that our vector adds from the front and the back. So if I add two things in, it's first in, last out. It's like a stack, like stacks of trays. So that's at least how I'm approaching things. So I'm going to put everything in a vector, and then what do we do for our vector? We said, well, it was not empty. There we go. I can just reuse that same vector actually. Text list dot push on the back. And I'm going to do so. Should that over, that down. So I'm going to get the top of my priority queue, push that thing, that text onto my vector. I'm then going to, then I need to pq dot pop my priority queue, remove the top element. All right. So I'm just going to push all these values onto my vector. And then when I get to my vector afterwards, I'm going to text list dot cast at get the last element. Get pop off the last element. And then it's going to be that particular element. All right. So what the heck am I doing? I said this was in reverse order. So you could say, I'm going to take the last element, move all the way down. I could also just throw things into a vector and then remove from the vector. It's like, how do I reverse cards? If I have a deck of cards and I want to reverse order the cards, what do? I take the top card, put it down, take the next card, put it on top of that, build up the deck of cards by just going top down, filling up another deck of cards. You'll see that they get reversed ordered. That's what we're doing here. So let's see what we get here. That's just one hacky workaround that we could do using our vectors, so I don't have to know how it works. By hello, by two, hello. And in the alphabetical order, the way I expect. Done and done. Because the priority queue is putting it into the correct, is putting it from the largest to smallest, not the smallest to largest. Okay. That was a lot of stuff on queues, vectors, and the like. All to say, we got them some bunch of built-in functions that can do stuff for you, and we want you to play around with it a little bit. Do you guys want to learn about Sorting, we can talk about sorting, but I can give entire lectures on that. I can talk about hash tables. That comes up and that confuses a lot of people. That's probably one of the biggest ones to confuse people. Um, Iterators themselves, what the heck they are, what they're useful for. Templated class, I would like to avoid that, at least for right now. What do you want to talk about? Other data structures again? Great. So what is a hash table? Sounds fancy, doesn't it? Or it sounds like a drug addict problem. Uh, it's neither, or at least I hope neither. Hash table is, how do I want to describe it? I say it in the videos, and I think it's the best analogy I can come up with. It's what the Dewey Decimal System gives you. It's what half of the things you have online give you. It is, it's actually what a DNS server, I think, also might give you. I pass in something to your system, like a string of text. I have some way of converting that to a number. That's all. That's all it is. Right. So if I have the DNS server, the domain name server, or service server, I type in google.com. That string goes to the DNS. The DNS converts that string into a number, which is the IP address for the closest Google server. It goes from a string to a number. A quick lookup so it can directly go to Google. That's all a hash table is. I pass in something like a string, like an object, something. It gets converted to a number, which happens to be ideally, the exact location where the data is stored. So if I say, okay, there you go, David Sprague, and you're looking for my office number. Okay, someone says David Sprague, and they say, oh, 130B. That's my office number. It's going from the name, converting it to exactly the box of where I am being stored. It's a straight up lookup. That's all it is. It's a look. It converts it to a lookup. Because what I ideally want is to just go, where is it stored? It's stored in box 42. Okay, I'm going to go straight to box 42. That's it. I can get to box 42. I know how arrays work. I have an array of 100 elements. I could just jump directly to box 42, to array index 42. That is constant time. I don't have to walk down the array or anything like that. If it's in 42, I go to 42. That's what I want. So I want some way of converting this object to go right here. That's what a hash table is. So let's do, hopefully I can do a hash table, or at least part of a hash table. So it's also in the assignment. It's also, I think I'd do an example, but why not do another one? All right. Anytime. Oh, class. Sync12. Great. All right. I'm going to make a class. I'm going to have how big, well, it doesn't matter how big, what you want it to be. And what are we storing here is the other question. So it depends on what we're storing. I'm going to store, let's say, an array of strings, string array. So I'm going to have a bunch of names. Okay. And then maybe I want int size, the number of things I can store in here. So this thing is going to store a bunch of names, a whole bunch of strings in this table. I can go into individual elements of an array. So what I want to be able to do is pass in a name and find exactly where to store it. Or if I pass in a name, you tell me exactly where it is stored. Maybe I have some other metric, or maybe I have some other thing like You pass me your student ID and I know exactly where your data file is. I don't have to pass the student in, I pass the student ID in. Some way of converting it to a lookup. So in our case, it's going to be a string that we're going to pass in, and it's going to find out if it's already in the table. And if it's not already in the table, it can maybe add it to the table, that sort of thing, or remove it from the table. And the table is just an array. That's all it is. There's nothing fancy here. I need to have the table size. I need to know how big this array is. But that's not the real interesting part of this. So Sync12 and we're going to make a table size table. Okay. Okay, that hopefully will do it. I need to put what this thing is doing. This is going to return an index or an integer. This is going to be void. It's not going to do anything at all. Or maybe I can return a value, but a Boolean maybe. It got added or not. Boolean, it got removed or not. Okay, I'm also going to need to I remember a long time ago when I used to be able to type. It was glorious back in those days. So hopefully I can make it as simple as humanly possible here. Here we go. Okay, what does this thing do? I need the size of my array before I get going. My constructor, I'm going to build my array. So what I want is this, and then let's put my array in here, is equal to new array of strings of size, table size, this. All right, that's it. That's, I made, oh, other than the fact I can't spell the word table. Highly overrated, this whole spelling thing. Okay, this thing is just going to make an array. Here's what the hash does. I'm going to take this name. I'm going to find a way of converting it to a number. I'm hoping that number is a unique number. And it has to be a number that's actually in my an index that's in my table. That's the gotcha. So name dot, and I get something like value capacity. No, that's not going to work. Signs. I want some way that'll actually do. So this is a string object. It has to be able to save a certain amount of space. Will that work? What I could do is oftentimes I'll use the pointer address as my number if I wanted to do that. Perfectly normal. The reason you do this is because, well, it's going to uniquely identify that item. Maybe I have in capacity, assign, cn, clear, compare, copy. Let me see if I can find something that's going to give me a number. That's all I care about right now. allocator. What does that do? No, insert length. Length might work. Maximum size might work. In place. Hey. Oh, we could do that. Okay, let's do that. So at position I. So here's what we're going to do. Int char total our sum. It is going to be insane, but let's just bear with me for a second. It's less than name dot length I plus. Okay, this is going to be a char. So char sum plus equal this. So I'm going to get the numeric value for each of the characters. Like A is what, 65 in ASCII. Capital A is that. Lowercase a is 97. I don't remember my ASCII numbers anymore. Good enough though. I've got a bunch of numbers. If I just add them up, the only difference is if I get an anagram of another word, like hello and if I just reverse the characters, it's still going to give me the same number, but I'm going to ignore that part. I just want a number. I care about. It could be the length of the string for a lot. It doesn't matter. But there's probably a lot more strings with the same, that are 3 characters long than the same character with the same size of a number. Notice that is not a valid index in my array. It's just not. This could be 4,000. I don't know what that number is, but table size could be 20. Right? It needs to be a valid index in my array. We will often make it even weirder. So we might do something like this. Char sum plus, after doing all this, plus equals 17. Okay, char sum is equal to char sum 123. I'm making something up here. Right. I just want to obfuscate and weird up the numbers a bit. Because unless it's the exact same number, I want to put it in a random position. Essentially, want to put it in a random position on my table. I wanted it to be random because if it's all the things go in the exact same position, what happens? I can't put more items in there. There's already an item in there. I'm trying to sort of scattershot where these items go into my table. If they all have a similar pattern, like let's say they're all 4 bytes different between them, they may not go. A bunch of them might all try and go in the same slot. I ideally want them to be distributed almost at random across all the different slots that I have in my table. All the different places I can put things, put it in there. I don't want to try and organize it. It's going to go into a random place. Okay. And the one last step that I will always do is this. Make darn sure. So what is it? Table size. Make darn sure it's a valid position in the table. So if it's 120, but the size of my table is 23, it's between 0 and 23. There is no exceptions. There's no changes. It always lands between 0 and 23. So this is going to give me some number between 0 and 23 or whatever my table size is. That's all a hash function does. The hash takes in some kind of data, crunches it up, or figures out some way of spitting out a number, and that number is where it gets stored in the table. All right, so if I want to add to my hash table, what do? I do int id x. I can do unsigned if I wanted to. Let's do an int id x equal to hash of the name. And if a names equal to, oh, I gotta fill those null, not, it can't be, I want to have nulls, don't I? I want an array of character strings. If I have actual strings, I won't know if I have filled up the table or not. It's an array of character strings. All right, should do, hopefully. All right, if a names at position idx is equal to null, then I'm going to fill this in. I'm going to have string new item is equal to new string name. I'm going to make a brand new string. Okay. And this is a string pointer. Should know that by now. It's a string pointer. All right. And then I'm going to have a names at idx equals new item. All right. For this one, I actually want to have a for I is equal to 0, I is less than size, I plus. Set all my value, my pointers to null, just to be on the safe side. I'm going to need a destructor as well, because I called new, I actually have to clear things up at the end. Sync12. When I'm done, I better clean this stuff up. I made a mess, I got to clean it up. All right, and I'm going to do this, and oh, I would also need to clean up this, so that's fine. So let's just, let me finish this before I forget how to do anything. And this, I want to check if a names does not equal null. Yeah. Well, all right. So for every one of the strings, I delete all the strings. When I'm done, when I'm finally done with my hash table, I delete all the strings inside the array, delete the array itself. Because I called new either here, I called new here, or when I make the new table, all new here for an array, I got to clean crap up. It's my job to clean it up when I'm done with it. All right. So that is me. I'm adding, I make a brand new string, add it to my hash table if there's nothing in that position. Otherwise, what do I want to do? Well, if otherwise else, I might want to say like something like see out grab hash table position was already filled. Oh wait, standard template library. I'm surprised this is telling me though. Good stream. Okay. If it doesn't work, I'm going to return false. If it does work here, I'm going to return true. All right. To remove something from my hash table, what do? I go here and I get the index if a names at idx is not equal null. If it's not equal to null, I'm going to have delete names at set that all safe values. So if there's something there, this thing says, hey, remove that particular element. What I could do if I want to be extra sure about this, and a names at idx equals, I think the double equals, will the double equals work? No. Okay. I want to just compare if name are the two pieces of text the same. So is there something in that part of the table already? Has the element already been added? If it has, if there's something in that table, I want to make sure that the string is the right string, the one I'm actually trying to remove. Otherwise, don't remove anything at all. And then I'm going to do an else statement without some kind of. Otherwise, graph at table position was not using name. All right. So if I'm trying to remove something, I check to see if the thing I'm looking for to remove is the thing I'm looking for. If it's not, don't remove it because somebody else's string, it's some other string. I can have collisions. I can have accidentally have two things going to the same slot if I'm unlucky. Well, actually, it's fairly common when I put a lot of stuff in here. And when I add something, I check to see if the slot is empty. If it is empty, add it. Otherwise, yell at the user. The reason why I have this is because I don't need to search the table. Now, technically, I have this little slow function here with it uses a for loop, but it has a for loop, but I didn't need to use a for loop. I could take a pointer. I have a constant time mathematical operation to tell me where this thing goes. That doesn't sound like much, but if I have 200,000 elements, walking down an array of 200,000 elements, pretty darn slow. Just at real time, figuring out the item where it's located, pretty darn quick. That's why people like hash tables. They're weird, they're quirky, but from a theoretical standpoint, at least, they're orders of magnitude, like actually more than an order of magnitude. They are provably faster in certain circumstances, as long as we don't have a collision. All right, so maybe I can do that, and let's make this include Sync12. So let's make a sync hash. Let's make a new sync hash. So what the heck? Why? Because I want to show you what new in action. Again, we get used to not calling new all the time. Sync hash. And it's going to take in, it needs to take in, why is that? It has two things. Should have a table size. So give me a table, maybe give me a number. Give me a prime number, a relatively, not massive, but an okay size prime number. If you can think of one. Doesn't have to be prime, but not prime. Nice. Close. It's close to a couple prime numbers, but 21, 7, and 3, which are both prime numbers, by the way. So that it's close. But 22 is not a prime number either, but there's a bunch of, let me think, 33 is not prime. It's 3 and 11. Is 31? I think 31 is. 39 is not. 37, I think 37 is. Let's try 37. We can also do 19 and 23. Okay. Why do I want a prime number, by the way? Because I want to make sure that I'm not going to have the math can actually work really badly against me. You can get weird patterns. If it's a prime number, it's less likely to have a lot of these collisions. That just happens to be the case. Okay, let's also hash dot add. And I want to add, what am I adding here? Hello. I use my usual hello world things. Let's do this as well. We're going to get an error with this. We should at least. I'm trying to add the same character, the same thing a second time. It shouldn't do it. I will then remove. And then I'm going to add it again. Why not? So I will add, and let's also change one more thing. I'm going to go to my hash table here. And every time I do this, I'm going to see out name. Removed. That should do it. I'm going to say when I added certain things. I just want some feedback. I'm really bad with this sort of thing. If I don't see the feedback, I don't know if I did it right. I want to see what happens. So here's what we have. I have a 37 element size array. I'm adding a couple strings of text. I'm really hoping they don't go to the same location, but we can add a whole lot of different text here. All right. Name, was added to position 20. Name blah was added at position 3. What's going on with that, by the way? I know what the bug is, but okay. Then we get there. Crap hash table position was already filled, which we expected. It's going to try and put it at position 20 again. It's the word hello. It's the first thing that we added. It went to the position hello. And then next time around, I add it to position 20. Sorry, remove from position 20. Then I add it to position 20. Notice no matter how many times I call this thing, it will go in position 20. Unless my array is a different size. My array is a different size, or I change some part of my hash function, it'll go to a different location. That's fine. But every single time I pass the same object in, it goes to the same location. It's consistent. even if it does random stuff. In case you're wondering where this comes in handy, I'm pretty sure that's actually how they do passwords for most of your systems. They have they salt the passwords, but effectively it is you put in a password, you put in a username, which then does a hash function to where the location is so they can check your password, but you cannot reverse engineer it. So if you don't have the username, you don't find the password, it's not listed in plain text. So there are all sorts of ways because I can pass in, if I pass in anything, a piece of a string into this thing, it will go consistently to the same place. But if I go to that place, I cannot deduce what caused me to go there. If I put some random like password in this thing, let's say, or I put some random other string, I can't deduce what is causing me to go into that position. I don't know anything about the hash function. I also don't know what the thing I'm looking up is. I can do a lot of information hiding with this because I have a one-way mapping from I go here, I eventually find this, it goes into this slot here. So what we'd hope for applications at BIT, that the applicant applies, we have a consistent response to the applicant or where they're positioned in a ranking system, let's say. You need to know how the ranking system works. No. If you are at a particular rank, can you deduce who the person it's for? No. You know there's a ranking system. You know that if one person applies, they get slotted into a particular ranking position, but you can't reverse engineer this thing. That's the beautiful thing about it. One of the other beautiful things about a hash table. Oh, sorry, you didn't see what I have here. Here we go. This is what the weird stuff I was talking about. This is weird. What the hell's going on there? Right? But here's the hello. Here's the world. I try and add hello again. I get crap. The position was already filled. The position where you would put it was already filled. I remove it. It's still at position 20 each time I do it. Every time I call the hash function, it gives me 20, no matter what. And then I try and add hello again, and it goes right back into position 20. It's consistent where it maps to. It's fast, it's consistent, but it's pretty much random if you do it right. Let's see what I did wrong, by the way. It's an array of string pointers. Dereference. Dereference. File it again. Okay. And if I run it, low position 20, 3, 20, 20. Hey, it's consistent, except let's do 31. Hopefully another prime number. Instead of 37, it's 31. And I'm hoping I get the right thing here. 26, 15, 26, 26. The hash function changed because the size of the array changed. And so it's going to map to a different location, but that's okay. It's still consistent. And it's always some number between 0 and the size of my hash table. That's why we do it that particular way. So all this is you pass in some data, it figures out an index to put it into a table, into an array, where it goes, it's consistently going to the same location. If I wanted to, let's see if I can do this a bunch of times. Let me see here. I don't know what this is going to do. But I do know that hello is going to go to 26 again. One of these other numbers, one of these other strings might also go to 26. We may have what's called a collision, but hello is going to go to 26. goes to position 26. 15, crap, some random thing happened. 20, by goes to 25. Hello, all capitals goes to 9. Hello goes to 26. 26. In fact, I have no collisions whatsoever. If I had a random text generator and threw, let's say 30 different words at this thing, eventually I will have a collision. But what I ideally want is at least 15 of these things go in first. That about you use about half, at most 3/4 of your hash table. So it takes up a lot of space, but it's fast. It has some really cool characteristics as well. That's a hash table. That's it. Now, if you can template a hash table, you'd be all set. That's where this thing, oh, I already had a hash table. There we go. Here's me adding, here's my hash function. This is a hash table taken in a particular ID. I'm just storing numbers in this thing. And what else do I have in here? And so an ID, I could just, here's some bunch of random math being done just to musty it up a little bit, right? I'm disturbing the waters a little bit. And then I have the array size, how big my array is, and I'm making sure that figuring out where that ID would be stored. I could get the particular hash. Based on the hash, I could say where to go in my array. And if I want to, so this is going to add, I can get the individual element, I can even remove, and I can remove elements from my hash table. All right. I've been talking a lot and not a lot of comments from you guys because I know you didn't watch the videos yet. So I'm hoping that makes sense. You'll see it in the videos again. You'll see it in the labs as well. It's a concept that is not weird once you get used to it, but it's really weird until you get used to it. It's until it suddenly dawns on you what the heck this thing is doing. It can be very confusing for a lot of people because they see the math and they go, "Holy crap!" And like, no, it's just some random math to hide the fact of what it's doing. That's all it is. It's random math to hopefully distribute your text to a whole bunch of different places. So that if I use the first character as the hash, let's say, to figure out the hash, I would have hello, uh, I would have hi, anything that started with lowercase h would all go to the same point. Not dumb question at all. I want it randomly assigned because I don't want collisions, and more. I also want to quickly look things up. If it doesn't work right now for you guys, luckily because we have a bit more diversity. Uh, but in the past, if you were in Newfoundland, because that's where I'm from originally, if you look up O's, what would there be a couple last names, like people with the last name C's for Churchill O'Brien. There's a couple of very, very common Smith, right? Very, very common last names. If you're in one of those letters, you got this big pile of O's, you get this big pile, like for exams, big pile of C's for Churchill, you get a big pile of S's for Smith and the like. And you'd have maybe, if you're lucky, one person with a last name that starts with a Z, right? Maybe if you're lucky, one person with a last name that starts with an X, right? It'd be really, really small groups on the other end. They're not evenly distributed across the way. What I want is evenly distributed. Randomization gives you some of that even distribution. That's just one of the huge parts. I may also want to hide where things are going because the last thing you want, one of the problems that you have with hash tables is people will go out of their way to try and break them. It's a hacking technique. If you want to screw up the other person's thing, you just keep on putting the same things in the same slots. Like you have a whole bunch of collisions to slow down their algorithm. It happens. And so you do want it evenly distributed so you can, if the more distributed it is, the faster it is for looking something up because you want it evenly distributed across the way. And if you don't know how the hash table is working, you can actually hide how all of these things hook together. It's a nicety of the whole thing, but really the ideal is evenly distributed. If you can figure out the mathematical formula to put everything in the same place. If you had a smart adversary who's trying to break into your system or is trying to cause you to have these collisions, which they have, then that's going to be a problem. They're going to give everybody with if you said, like, let's say grade distribution, let's say, let's everybody, and I probably should bring that up too. Grade distribution. If you have everyone, like if you put everyone, you use a person's grade for exam 2 as the index for where you store their exam, you're going to get clumps where there's a whole lot of exams in one place. That's not ideal because now you have to walk through that individual exam, that bucket with 20 exams. To find that person's name, I got to go through that bucket of 20 exams. That's effectively the reason. So it's not a stupid question at all. At all. So let me just be very clear because I'm going to talk about it in the email. The exam 2 mark was low. That I think said something about the exam being too difficult for you guys, not necessarily what you're capable of. I think that we can actually do, I normally don't do any kind of curving until the end, just because if I curve like on exam 2, and then if the final exam is too easy, you can't uncurve. You can't, like, we've had that the very first term I taught in the university. One exam, they had like it's like a 70%, but at Northeastern, people freak out with 70%. Maybe it's even lower than that, but people were freaking out. They were like, oh my gosh, the students are going to freak out. So they curved it by about 5 points. The final exam, people were walking out of the room high-fiving each other. The average was like a 90 or higher, way too high. And you can't uncurve that. You cannot say, like, let's grade extra hard. You can't undo that. And so the best thing you to do is you had the 90, you had the original crappy exam, they nullify each other. So I might try and make the final exam a little easier, but at the very least, I can't, like, the average was, I think, just north of a 50% average. That's way too low. It should be like 65, 70% range. So the final exam's got to be a lot easier. And then I also, where the border ends, I can sort of nudge things over. I don't need you to do much, but I'm also not going to make a really stupidly easy exam, but it's going to hopefully be easier. Oh, you didn't look up your mark yet. Okay. They're all up, by the way. So you can look up your marks. My 1400 class, the average was, I think, between 66, I think it was about a 66%, maybe ish, 2/3. This was on the low side, but I think anyone that got over a 30, you're fine. Below 30, ask for help. The easiest thing for me to do is say, hey, the exam's marked out of 60, but that's still, it's even easier and perhaps safer to just sort of curve the marks at the end. All right. How was that, everyone? That was me talking for way too long. I've been yammering on here. Other questions? Otherwise, I'll let you guys go. Stop sharing the screen, I suppose. Nada? All right. In that case, I'll let you go. I'll post this up soon. And yeah, I'll hopefully upload it tonight. And the code should already be online. So that is, what is it under? It is Sync12 STL exam 2, but it's from F20. Probably should rename that one, but yeah, that's what we're looking at right now. All right, perfect. All right, talk to you later, guys. Thank you.